Math Humans. We're going to do 7.5 today. We're going to be talking about systems of inequalities. Our objectives are that we're going to solve systems of inequalities by graphing and then shading and then reporting. So for the first example, we're going to talk about a graphing reminder. So if I have y is greater than or equal to x squared minus 1. In this particular problem, let me get a different colored pen. Because there is the equal portion of the inequality, that means that the line is included in the solution of the graph. So if I graphed this parabola, it has a y-intercept of a -1, and then it would cross like this. So the line would be part of the solution, and then I would shade everything that is greater than. Sometimes it's hard to know if a point is greater than or not, and so you can, if you'll remember, way back from probably Algebra 1, choose a point. So if I let x be 0 and y equal 0, the question is 0 greater than or equal to a -1? And that would be a true statement, so that means that I would shade the part where the point is included. Alrighty, let me show you how to do this in your handy-dandy grapher. I don't like doing these in my calculator because I think they take a lot of time, but sometimes it's nice to help you if the graph is a little bit more complicated. So if I put in x squared minus 1, then what I'm going to do is I'm going to go over here to the left, and I'm going to hit enter. And notice that I don't care about the color, but in this one, now I'm going to change, and if the triangle is above, that means greater than, so I would hit enter and OK. And notice that my little triangle is above, and then if I hit zoom 6, it's going to graph the function and the shaded area. So that's actually kind of cool. It becomes a little bit complicated, especially in the next section, and sometimes it's nice to turn that off. If I want, I just go back to my y equals, go over here, hit enter, and then I just go back to the regular line, hit enter, and then I'm back to where I started. So that's how we do that in our calculator. All right, the second example. So for example 2, we're going to have solve x minus y is less than 2. So to do that, I want to be able to graph. So I'm going to do a -y is less than 2 minus x. I need to multiply through by a -1. Remember though, if you multiply or divide, when you're solving inequalities, it's going to make this sign switch. If you add or subtract, it doesn't matter. So it's only if you multiply or divide. So I'm going to get y is greater than x minus 2. So then I'm going to come over here and I'm going to do this one by hand because it's really pretty easy. So this is a -2. My slope is up 1 over 1. Notice that I don't have the equality portion, so that means that 2 points define a line. The line is not a part of the solution. So there's my line. And then it says y is greater than. So if I chose the point 0, 0, so x is 0 and y is 0, I want to know, is 0 greater than a -2? Yes, that's true. So then I would shade this side of the line. And when I shade that, the solution set is everything inside the shaded area, not including the line. All right, for the next example, we're going to do a system of inequalities. So when we're looking at a system, we're looking for the overlapped area. And let's just do our equations. I have x minus y is less than 2, x is greater than a -2, and y is less than or equal to 3. So I'm going to rearrange these equations to make sure that they are in standard form. So this one is a -y is less than 2 minus x, or y is greater than x minus 2. This is a vertical line, and this is a horizontal line. So if I graph this system, okay, so I have, this is the line that we just did in the last column. Here's a -2. My slope is up 1 and over 1. So there's going to be this line. This line's not included. Okay. For the next one, x is greater than a -2 is a vertical line. And again, it's not included, so I'm going to make it dashed. So I had shaded from the first line this way. Greater than a -2 is this way. So now it's shaded this way. And then y is less than or equal to 3. So 1, 2, 3. Less than or equal to means it's a solid line, so the line is included, and so then it's this way. So you can't see it. Maybe I'll get out my handy-dandy highlighter, but including that line and this area in here would be the solution to the problem. So for these particular problems, when you graph, we want to look at the vertices, okay? So you would want to label those vertices with coordinates, okay? You can put these systems in your calculator. Putting a vertical line in your calculator is a little bit entertaining. I recommend just graphing by hand, and usually this information is pretty easy to figure out. So the systems that we've done so far have been linear. Now let's do one that maybe isn't quite linear. So let's say, for example 4, I want to solve the system. And my equations are going to be x squared minus y is less than or equal to 1. So remember, if it has the equality portion, that means that the line is going to be part of the graph. And a -x plus y is less than or equal to 1. So there's my little system. I'm going to rewrite my equation. So I have a -y is less than or equal to 1 minus x squared. And then this one changes to y is greater than or equal to x squared minus 1. The second equation, y is going to be less than or equal to x plus 1. And then that's it. Okay? And I'm actually going to do this one in my calculator just to show you how to do this again. So I'm going to go over here and I'm going to clear, and I have x squared minus 1. This one is greater than or equal to. So I'm going to change my line to be greater than. Remember, greater than is above. My second equation is going to be, we'll go ahead and change this part, less than or equal to. So it's going to be below. And then my equation is x plus 1, and then I'm going to graph. There's the first equation, there's the second equation, and let me bring this up a little bit so you could see. Notice that the overlapped area would be, it's really unfocused, I'm sorry. The overlapped area would be the solution, and then I would be responsible to label those vertices. So if I graphed these, actually, let me show you how to do that in your calculator, because sometimes that's handy. So what I'm going to do is I'm going to go back and take the shading off. And I'm going to do that for the second equation as well, because the shading actually gets kind of annoying when I am trying to manage that part. So there's my lines, and OK, and graph. So then if I sketch my graph, I have this cute little parabola, and then I have this line. And so I can find those 2 points of intersection in my calculator. This is the cross-hatched area. And if I just do second calculate 5 for intersect, I'm going to get a little bit closer, inner, inner, inner. It tells me that the coordinates of this point are -1, 0. And then I could do it again, second calculate intersect. I'm going to cruise back around, close, that has to be exact, and that point is at 2, 3. So that would be the expectation when I am reporting, putting my cute little arrows on my graph so that it looks appropriate, and I would need to label the shaded area and the vertices. All right, that wasn't too difficult. I think that's it for today. We will do more of these tomorrow, and I will see you soon.